I hope enough time has elapsed since our last lecture so that you feel at home doing arithmetic of complex numbers, because you see now what we'd like to do today is the next phase that leads into our calculus study of complex numbers. Namely, what we would like to do is study functions of a complex variable. And again, in terms of a function machine, I'm visualizing the input of my machine being a complex number and the output being a complex number. By the way, I should mention that there are situations, and we'll cover these in the homework exercises, where one sometimes likes the input to be a real number and the output a complex number, or the input a complex number and the output a real number. But for reasons that I hope will become apparent in a moment, we're going to focus our attention on the case where both the input and the output are complex numbers, noticing that if we do that, especially from a geometrical point of view, a vector point of view, our input is a two-tuple, say the complex number x comma y, or x plus iy is represented by the two-tuple x comma y. The output w equals f of z is what? U plus iv, say, or as a two-tuple u comma v. The idea being that graphically we can view a function that maps the complex numbers into the complex numbers as a mapping from the xy plane into the uv plane, where the complex number z is identified with the pair x comma y. The complex number w is identified with the ordered pair u comma v. The xy plane is the domain of our function. The uv plane is the range of our function. By way of example, suppose I take the function f of z equals z squared. Recalling that z is x plus iy, if I square this, I get as the real part x squared minus y squared. The imaginary part is 2xy. So as a two-tuple type mapping, f maps x comma y into x squared minus y squared comma 2xy. In other words, u is x squared minus y squared, v is 2xy. So that in summary, notice that the complex valued function of a complex variable, in other words, we're mapping complex inputs into complex outputs, but that particular mapping, f of z equals z squared, is equivalent to the, and this is important, to the real system of equations, u equals x squared minus y squared, v equals 2xy. You see, this is a system of two real equations and two unknowns, and what I'm saying is that I cannot distinguish between this problem and this problem. In other words, somehow or other, studying complex valued functions is going to help me replace, or to view from a different vantage point, the study of systems of real functions. But again, more about that as we proceed. At any rate, leaving further drill, we haven't done any drill, leaving drill to the exercises, because I think conceptually this is all old hat. And why do I say it's old hat? Well, heck, we've spent a whole block of material working on these kind of mappings. Also, geometrically, we're viewing the complex numbers as being vectors, so that, in another manner of speaking, complex valued functions of a complex variable are equivalent to what? Functions that map two-dimensional space into two-dimensional space, and we talked about that in our treatment of vector functions. So whichever way we look at this thing, I think that the drill is fairly straightforward.